multi-stage amplifiers are basically uh, adding or cascading or connecting. Connecting or cascading. Cascading means nothing but the connecting more number of stages in series with each other. So the output of the first one amplifier is given as the input to the next amplifier. Similarly, the output of the second amplifier is given as the input to the third amplifier. Like that, we are increasing the number of stages. When these number of stages are increasing, and so how we are going to connect one amplifier to the other amplifier. That is nothing but the coupling. That means we are going to connect or cascade one stage to the other stage. We call it as a cascading of amplifiers. So how we are cascading or connecting one stage to the other stage is with the help of some components. So that is called the coupling. We are going to couple one stage to the other stage with the help of some components. The basic components which we are going to use while we are coupling is resistor, capacitor and the inductors or transformer. So with that we have basically three types of coupling. Coupling means using the components to connect the multi-stage amplifiers. This is nothing but the coupling. That means connecting one stage with the other stage. So whenever we are connecting one stage with the other stage, we have three types of coupling. One is direct coupled, the second one is RC coupled, and the third one is transformer coupled. Sorry, no, I received a call. That's the reason why it's disturbed. Okay, right. So multi-stage amplifiers and the connecting one stage to the other stage to increase the gain, in which we have three types of coupling. Coupling is nothing but using some components to connect one stage to the other stage. We have three types of coupling: direct coupled, RC coupled, transformer coupled. So direct coupling means we are not using any components to couple one stage to the other stage. That means directly the single stage amplifier output is given as an input to the next stage of amplifier. Let me share this screen. Can you able to see the screen now? Can you able to see the screen? Hello? Hello?
Yes, ma'am.
Can you able to see the screen? Hello?
Yes, ma'am.
ఒకళ్ళని ఆన్సర్ చేయమమ్మా స్క్రీన్ కనిపిస్తుందా స్క్రీన్ షేర్ చేశాను కనిపిస్తుందా
Yes, ma'am.
హలో ఆన్సర్ చేయడం. Hello, I'm presenting something. Can you able to see the screen? Hello? Hello? 310. Can you see the
Yes, ma'am.
screen?
Yes, ma'am.
Okay. So, no, this is state multi-stage amplifier means connecting a number of stages. So this the way which we are going to connect one stage to the other stage is called the coupling. Okay? So while you're coupling, three types of coupling. One is, as I said, is a direct coupled. Second, RC coupled. That is transformer coupled. Okay. So direct coupling means no components are used. Directly the output of the first stage is given as the input to the next amplifier without using any components. Is called the direct coupling. What are the advantages of direct coupling? What are the advantages of direct coupling? Whenever we are directly giving, there is no loss of any signal. The first stage into second stage, the signal is directly given along with the DC. So that the DC signal is also given from stage 1 to the stage 2. Hence, direct couple is basically used to amplify the DC direct signals, amplify the DC signals. Amplify DC signals, we are using amplifying the DC signals, we are using the um, direct coupling. So, what are this is one advantage. What are the disadvantages of using the direct coupling? The basic advantage of direct coupling is you can able to amplify the DC signal because there is no component that is blocking the DC signal. Whatever signal starting from zero frequency to the maximum frequency, signal can able to amplify. But what is the disadvantage with this particular type of direct coupling? So direct coupling, you can amplify both AC as well as DC signals. So DC amplification is perfectly done. But what happens to the AC amplification signal? ఏమవుతుంది ఏసీ amplification? One stage నుంచి other stage కి when the DC signal is given without blocking the DC from first stage to the second stage, DC is given. What happened? The second stage biasing. So we are already fixed this biasing. Biasing అంటే ఏంటి? DC voltage is applying DC voltage with the base to emitter voltage, base to emitter and the collector to emitter signal. Base to collector and base to emitter signal. We are applying some DC voltages to make the amplifier work in the active region. So applying ultimately because of the direct couple, the DC signal is also given. The DC signal is given to the second stage, which is going to disturb the biasing of the second stage. So second stage amplifier ki already we have fixed the Q point exactly at the middle of the load line with the help of DC biasing. So because of the DC that is transferred from first stage to the second stage, the effect of biasing in the second stage is going to be disturbed. So the biasing, second stage biasing, the biasing of the second stage is disturbed because of the DC signal that is transformed from first stage to the second stage. So DC biasing is going to be disturbed. DC biasing disturb అయిందంటే ఏమవుతుంది? Biasing అంటే ఇలా ఉంది. Q point is selected initially. So because of the first stage, now the Q point is moved from center point to either this point or this point అనుకోండి. This or this or this A or B కి మూవ్ అయింది. అప్పుడు ఏమవుతుంది? ఇక్కడ మూవ్ అయింది అంటే the signal amplification is reduced now. ఇక్కడికి మూవ్ అయిందంటే the signal amplification is reduced. That means either you can get positive clip or negative signal is going to be clipped off. So amplification అయినా కూడా the AC signal is going to be distorted. So what are the disadvantages? First is DC biasing is disturbed. Second is because of the variation in the DC biasing is disturbed. Okay? Because of the DC biasing variation, we will get amplitude distortion. Why I am saying it is an amplitude distortion? Because the amplitude of the signal, signal, you will get this type of wave. ఒకవేళ క్యూ పాయింట్ ఇక్కడ సెలెక్ట్ చేసుకుని అనుకుంటే యూ విల్ గెట్ దిస్ టైప్ ఆఫ్ సిగ్నల్. అంటే ఏమైంది? ఇక్కడ వచ్చే ఈ పీక్ డిస్టర్బ్ అయింది, ఈ పీక్ డిస్టర్బ్ అయింది. దట్ మీన్స్ amplitude is distorted. So amplitude distortion occurs if you are doing direct coupled. Okay. మరి ఇలాంటప్పుడు మనం why we are using this means this direct coupling is basically used in the operational amplifiers. I think you have already studied the PDLIC lo we are studying the operational amplifier, wherein the block diagram of operational amplifier consists of 4 blocks, right? First the dual input balanced output, second the dual input unbalanced output, next level shifting, next the complementary symmetry power amplifier. ఈ 4 blocks ఉంటాయి కదా, దాంట్లో how we are coupling the first stage to the second stage using the direct coupling. Because of the direct coupling used in the operational amplifier, AC as well as DC signal, both signals can be amplified using op amp. That is the advantage. That means where we are using this DC coupling is basically used. The applications of DC coupling is used in the operational amplifiers. Direct coupling is used in the operational amplifiers. So operational amplifiers to first stage into second stage, direct coupling is used. For coupling components, we are not using anything. We are using direct coupling so that DC signal also can be amplified with the maximum gain. Okay. So this is direct coupling. So direct coupling, the advantages of direct coupling is direct coupling can be used in for the amplifying the DC signals. Disadvantages of DC coupling is it disturb the DC biasing of the next consecutive stages. ఇది first stage. Second stage ఏమవుతుంది, ఇది దీనికి consecutive stage అవుతుంది. So next consecutive stages లో DC biasing is disturbed. The consecutive stages of amplifiers, DC biasing is disturbed. Because of this DC biasing is disturbed, definitely we'll get the amplitude distortion. It means we cannot able to amplify DC signals much. AC signals must, whenever we are having maximum gain ఎక్కువ ఎక్కడైతే పాసిబిలిటీ ఉంటుందో అక్కడ మాత్రమే we can able to use this direct coupling. So in operation amplifier, the ideal characteristics of operation amplifier ఏంటి? Op-amp ideal characteristics is its gain is infinity. So op-amp gain is infinity. That is the reason why operation amplifier లో DC coupling is used to get the infinite gain in both AC as well as DC signals. Okay, that is DC coupling. So the advantages, the disadvantages, if applications. Application is basically direct coupling is used in the op amps, operation amplifier. This operation amplifier ICs లో మేము బేసికల్గా దీన్ని యూజ్ చేస్తాం. నెక్స్ట్ సెకండ్ is RC coupling. As we have already studied about the RC coupling. RC coupling అంటే ఏంటి? The coupling in between first stage and second stage, we are going to connect the between first stage and second stage, we are going to connect the capacitor, which we call it as coupling capacitor. CC. ఇక్కడ ఏంటి, ఇక్కడ amplifier అంటే amplifier circuit ఏంటి? Simple amplifier circuit, transistor, right? This is RC, RE, ఇది stage. ఇక్కడ నుంచి డైరెక్ట్ కప్లింగ్ అంటే అవుట్పుట్ ఆఫ్ దిస్ ఇస్ డైరెక్ట్లీ గివెన్ టు ది ఇన్పుట్ ఆఫ్ ద నెక్స్ట్ స్టేజ్. ఇప్పుడు RC coupling అంటే we are going to connect a capacitor here. Through the capacitor CC, the output is given to the next amplifier. Okay, so that is called we call it as the RC coupling. Okay, that we call it as RC coupling. So coupling is done with this amplifier, wherein the output of the amplifier is connected. Output of the amplifier is connected through the capacitor, coupling capacitor, to the next stage of amplifier. This is called RC coupling. Why we are calling it as RC coupling? Because this is the coupling capacitor and output is through the collector resistor. From the collector resistor we are collecting the output, hence it is called R and C combination. This is called RC coupling. So what are the advantages of RC coupling? చెప్పాలమ్మా మీరే చెప్పండి, ఆల్రెడీ చదువుంటారు చెప్పండి. What are the advantages of RC coupling? Simple in construction, right? Simple in construction. Second advantage ఏంటి RC coupling తోటి because there are no losses. No losses occur. Either it is an amplitude distortion వస్తుంది కదా దీంట్లో. The biasing is not affected because of the coupling capacitor. What is the purpose of the coupling capacitor here? The capacitor ఎందుకు పెడుతున్నాం? To block DC. It will block DC. Because it is blocking the DC, the disadvantage is direct coupling లో రెండు disadvantages ఉన్నాయి. Direct coupling లో ఏంటి two disadvantages there. What are the two disadvantages in the direct coupling? One is it is disturbing the DC. అంటే DC biasing disturb చేస్తుంది. That means the first stage నుంచి second stage కి DC has to be stopped or blocked. So to అది DCని బ్లాక్ చేయడానికి ఏం యూజ్ చేయొచ్చు? We can use the capacitor. So if you use a capacitor, it will block the DC and allow only AC signal to the next stage. Because it is blocking the DC is blocked. Because of the blocking in DC, the biasing of the next stage is not affected because of the preceding stage. Preceding stage or previous stage. ఇది consecutive stage అంటే next stages. Preceding stage or preceding stage అంటే previous stage. Okay, so because of the DC voltages that are not blocked in the first stage, the preceding stage లో next stage లో ఇక్కడ no DC biasing affected. No DC bias. DC biasing is not affected. Okay, not affecting DC biasing. ఇది డిసడ్వాంటేజ్ దేంట్లో డైరెక్ట్ కప్లింగ్. సో డైరెక్ట్గా ఒక స్టేజ్ నుంచి ఇంకో స్టేజ్కి కనెక్షన్ ఇచ్చేయచ్చు. ఇచ్చేస్తే వీఆర్ హ్యావింగ్ టూ బేసిక్ డిసడ్వాంటేజెస్. టు అవాయిడ్ దట్ వీఆర్ యూజింగ్ capacitor. What because of the addition of this capacitor, what are the advantages? Not affecting the biasing. So because that biasing is not affected, full load line is used. Okay? Full DC load line is used. Full DC load line is used, and because of which no amplitude distortion. Okay, no amplitude distortion because of the simple component. The capacitor is a simple component. By adding this component, the circuit size, cost, and weight is very less. Okay? When compared to the direct coupling, we are including one small component called capacitor. By including the small component capacitor, the size, weight, and cost of the circuit is not much increased. So these values are less only. So the size, cost, and weight of this amplifier, this coupling, capacitor RC coupling is less. But what are the basic disadvantages? The advantages. So we can say that size, cost, weight is less. Okay, so this is very values of size, cost, and weight are less in RC coupling. What are the disadvantages? What are the disadvantages in using this? The first basic disadvantage in the we are connecting capacitor here. So when we take the equivalent circuit, in the mid frequency range, or at low frequency or high frequency, or at low frequencies, when we take the equivalent, because of this capacitor, gain is falling at low frequencies. Because of this coupling capacitor, gain falls at low frequencies. Okay? Gain falls at low frequencies. In the book, I think we have already studied this. Gain is the frequency response, right? This frequency response. Ikkada, this gain, when compared to this, is called the mid-band frequency gain, maximum gain. Mid frequency gain. This is called gain at low frequency. This is called gain at high frequency. Okay, gain at low frequency, when compared to the gain at mid frequency, it is falling. The gain fall is because of the coupling capacitor CC and emitter bypass capacitor CE. అంటే coupling capacitor connect చేసినందు మూలంగా the gain is falling at low frequencies. That is the first disadvantage. Gain falls at low frequencies because of the coupling capacitor. Okay, gain and this is coupling capacitor is one of the reasons for falling of the gain at low frequencies. ఇది first disadvantage. Second ఏంటి? What is the second disadvantage? When we consider the mid-frequency range లో consider చేసినప్పుడు ఏం చేస్తాం? All capacitors are eliminated. అంటే అన్ని capacitors ని short చేస్తాం. When all the capacitors are short circuited, what is the net effective load of the first stage? Load ఏమవుతుంది? Equivalent తీసుకున్నప్పుడు. This is I'm talking in terms of equivalent. Equivalent తీసుకున్నప్పుడు RC resistor ఏమవుతుంది? This is going to connect you between output terminal and with respect to ground. RC ఇది RC resistor. ఇప్పుడు సెకండ్ స్టేజ్ యాంప్లిఫైర్ ఉంది. ఇది A2, ఇది A1. ఓకే, ఇది A1, ఇది A2. సెకండ్ స్టేజ్ యాంప్లిఫైర్ ఏమవుతుంది? సెకండ్ స్టేజ్ యాంప్లిఫైర్ దగ్గర ఇన్పుట్ రెసిస్టెన్స్ RI ఉంటుంది. ఇక్కడ ఇన్పుట్ రెసిస్టెన్స్ RI. దిస్ ఇస్ ఇన్పుట్ రెసిస్టెన్స్. ఇన్ బిట్వీన్ బేస్ టర్మినల్ అండ్ ది గ్రౌండ్ టర్మినల్ we have RI. ఇప్పుడు ఇది ఫస్ట్ స్టేజ్ RC. ఇది RC కదా, ఫస్ట్ స్టేజ్ RC and second stage RI. Both are in parallel with each other. When two resistors are in parallel with each other, net effective resistance will be equal to the lowest value of the resistance, like RC RI by RC plus RI. అంతే కదా, నెట్ ఎఫెక్టివ్ రెసిస్టెన్స్ రెండు ప్యారలల్ గా ఉన్నప్పుడు what is approximate value of this equivalent resistance RC RI by RC plus RI? The value of RI input resistance is low in case of CE amplifier. We know that the input impedance of the CE amplifier is low and RC value is high, RI is low. When high resistance is in parallel with the low resistance, net effective resistance will be always low. The high resistance in parallel with the low resistance, the net effective resistance will be always equal to the low effective resistance. అంటే RI అవుతుంది. నెట్ ఎఫెక్టివ్ రెసిస్టెన్స్ RI. అంటే ఏమవుతుంది? ఇక్కడ వోల్టేజ్ డ్రాప్. ఇప్పుడు ఇక్కడ వోల్టేజ్ డ్రాప్ ఉంది. we call it as this is a V out of the first stage, right? ఇది V in. Okay, V out of the first stage must be equal to the V in of the next stage. అంతే కదా, మనం రెండు క్యాస్కేడ్ చేస్తున్నాము అంటే ఈ ఫస్ట్ స్టేజ్ అవుట్పుట్ షుడ్ బి ద ఇన్పుట్ ఆఫ్ ద నెక్స్ట్ స్టేజ్. అప్పుడైతేనే మనకి గెయిన్ ప్రాపర్గా వస్తుంది. బికాస్ ఆఫ్ దిస్ ఎఫెక్ట్ ఆఫ్ టూ రెసిస్టెన్సెస్ RC and RI, net effective resistance is decreased less when compared to the RC. ఇప్పుడు ఇది హై రెసిస్టెన్స్ RC, ఇది లో రెసిస్టెన్స్ RI. రెసిస్టెన్స్ తగ్గింది అంటే వోల్టేజ్ డ్రాప్ ఏమవుతుంది? ఆటోమేటిక్గా తగ్గిపోతుంది. RI తగ్గింది కాబట్టి V ఈక్వల్ టు I ఇంటూ RI, V ఈక్వల్ టు IR కదా. RI తగ్గింది, దట్ మీన్స్ వోల్టేజ్ డ్రాప్ డిక్రీజెస్. సో వోల్టేజ్ డ్రాప్ డిక్రీజ్ అయిందంటే ఇక్కడ వోల్టేజ్ డ్రాప్ డిక్రీజ్ అయింది. ఇన్పుట్లో సెకండ్ స్టేజ్ ఇన్పుట్లో వోల్టేజ్ డ్రాప్ ఇస్ రెడ్యూస్డ్. Voltage drop at the input of the second stage is reduced. Because of this we call it as what we call as loading effect. Okay, this we call it as loading effect. Okay, so we call it as loading effect. So gain falls at low frequency because of the coupling capacitor. This is one disadvantage. Second is it occurs loading effect. What is loading effect is the net effective resistance offered at the input of the next consecutive stage is decreased. because of which the actual voltage అంటే ఈ అవుట్పుట్ V నాట్ ఈజ్ నాట్ ఈక్వల్ లోడింగ్ ఎఫెక్ట్ మూలంగా ఏమవుతుంది అవుట్పుట్ ఆఫ్ ఫస్ట్ స్టేజ్ అంటే V నాట్ 1 ఈజ్ నాట్ ఈక్వల్ టు V ఇంటూ కానీ మనం థియరిటికల్గా చెప్పేటప్పుడు ఏం చెప్తున్నాం రెండు కనెక్ట్ చేసినప్పుడు ఫస్ట్ స్టేజ్ సెకండ్ స్టేజ్ కనెక్ట్ చేసినప్పుడు V నాట్ 1 ఈజ్ ఈక్వల్ టు V ఇంటూ అని క్యాలిక్యులేట్ చేస్తాం కాబట్టి విల్ గెట్ మాక్సిమం గెయిన్ అయితే వస్తుంది బట్ ప్రాక్టికల్గా ఏమవుతుంది V నాట్ 1 ఈజ్ నాట్ ఈక్వల్ టు V ఇంటూ that is called loading effect. Because of the loading effect, the output of the first stage is not equal to the input of the next consecutive stage. దీని మూలంగా ఏమవుతుంది గెయిన్ థియరిటికల్ గెయిన్ ఎంత ఉండాలి ఓవరాల్ గెయిన్ విల్ బి ఈక్వల్ టు ప్రోడక్ట్ ఆఫ్ ఇండివిజువల్ ఫస్ట్ స్టేజ్ గెయిన్ మల్టిప్లైడ్ బై ద సెకండ్ స్టేజ్ గెయిన్ రావాలి బట్ because of the loading effect this gain is not equal to the product of individual voltage gains but this value is less when compared to the actual theoretical value. This value is less when compared to the actual theoretical value which we call it as a loading effect. Right? So gain falls at low frequency and because of the loading effect, theoretical gain is not equal to the practical gain. So theoretical gain is not equal to practical gain. Okay, theoretical gain is not equal to practical gain because of the loading effect. Okay, income disadvantages. These are the only two disadvantages which occur. And loading effect తగ్గాలంటే ఏం చేయాలి because loading effect ఎందుకు వస్తుంది because of the mismatch of the load resistance. So impedance matching is not possible because there is no impedance matching. Because of no impedance matching, loading effect occurs. Okay, because of no impedance matching, loading effect occurs. So these are the basic three disadvantages of the RC coupling. And the advantages into frequency response is perfect frequency response. We get perfect frequency response. The size, cost, weight of the RC coupling is less. There is no amplitude distortion. Full DC load line is used. There is no biasing is not affected because of the DC because we are blocking the DC with the help of coupling capacitor. No DC effect will be there on the next stage. So these are the advantages. So disadvantages in the three. Gain falls at low frequency. Loading effect occurs because of the because there is no impedance matching occurs, loading effect occurs. Because of the loading effects, the theoretical gain is not equal to the practical gain. So these are the disadvantages. So to avoid these three basic disadvantages, ఇక్కడ నుంచి ఇక్కడ వరకు ఉండే basic three disadvantages ని avoid చేయడానికి we are going ahead with the transformer coupled. What is meant by transformer coupled? Okay, transformer coupled అంటే ఏంటి ఇది amplifier. Right? This is one amplifier. This is another amplifier. Okay, transformer coupling అంటే ఏం చేస్తాం first stage load now replaced with the transformer. First stage అంటే the amplifier 1, amplifier 2. Then the amplifier both are going to be connected with the help of a transformer. Output direct coupled అంటే డైరెక్ట్ గా కనెక్ట్ చేస్తాం. కెపాసిటివ్ కపుల్ అంటే ఫస్ట్ స్టేజ్ నుంచి సెకండ్ స్టేజ్ కనెక్ట్ చేస్తాం. ఇప్పుడు థర్డ్ స్టేజ్ అంటే ఆర్సీ కప్లింగ్. నౌ ఇట్ ఈస్ ట్రాన్స్ఫార్మర్ కపుల్ wherein first stage to second stage connection between first stage and second stage is done with the help of transformer windings N1 and N2. Thus, with the help of transformer we are connecting the one stage to the other stage. So ఇది ట్రాన్స్ఫార్మర్ కనెక్ట్ చేసినప్పుడు ఏమవుతుంది how we are connecting the transformer. ఈ ట్రాన్స్ఫార్మర్ ఎక్కడి నుంచి కనెక్ట్ చేస్తున్నాము విత్ ద హెల్ప్ ఆఫ్ ద లోడ్ రెసిస్టెన్స్ డైరెక్ట్గా సప్లై నుంచి ట్రాన్స్ఫార్మర్ కనెక్ట్ చేస్తున్నాము దీని నుంచి అంప్లిఫైర్కి వెళ్ళిపోతుంది. The output of the transformer this is connected to the base terminal, this end is connected to the ground terminal. Okay, so this is connected to the base, this end is connected to the ground. So So this is called the transformer coupling. Transformer coupling means that two amplifiers or in the multi-stage amplifiers, connection between one amplifier to the other amplifier is done with the help of transformer. We have transformer generally N1 into N2 ratio transformers. Whenever you are using a transformer, ఇక్కడ effective load resistance ఏదైతే ఉందో load resistance we call it as RL dash, and here we are going to connect the input resistance. దీని input resistance RA వస్తుంది. Okay, ఇది RL dash, ఇది RA. Input resistance RA for the transform next stage amplifier. That will be the load resistance of the first stage. దీనికి input resistance ఏమవుతుంది RL dash. The load resistance of the first stage will be the input resistance of the next stage. This way we are going to connect the transformer. So how these two values are related, RL dash and RA. Always the values of RL dash by RL, the primary to secondary turn ratio will be equal to secondary turns ratio by primary turns ratio whole square. This is the relationship between the number of turns and the resistance. So currents, voltages kuda ade ratio lo they are going to be connected. So so this is how we are going to connect the transformer. So what are the advantages of using this transformer coupling? Okay, applications చెప్తారు కదా నేను అంటే ఆర్సీ కపుల్డ్ అప్లికేషన్స్ ఏంటి, వేర్ విల్ యూజ్ applications in all stages where we use them as preamplifiers. RC coupling is used in preamplifiers in all transmitters and receivers. In all transmitters and receivers. And transmitters receiver lo preamplifiers laga RC coupling is used. Okay, DC coupling ఏమో ఆప్ ఆంప్స్ లో యూజ్ చేస్తాము. RC coupling ఏమో transmitters and receivers లో pre-amplifiers అంటారు. Pre-amplifier is nothing but first stages of amplifier. Pre-amplification means initial stages of amplification. Signal ని initial గా amplify చేయడానికి initial stages of amplifiers. So we are using pre-amplifiers. So we are using RC coupled. Transformer coupled. Advantages of transformer coupled ఏంటి? What are the advantages? మీకు ఆల్రెడీ చెప్పారు. డైరెక్ట్ కప్లింగ్ వల్ల డిసడ్వాంటేజెస్ని అవాయిడ్ చేయడానికి వీఆర్ యూజింగ్ ఆర్సీ కప్లింగ్. ఇప్పుడు ఆర్సీ కప్లింగ్లో వచ్చే డిసడ్వాంటేజెస్ని అవాయిడ్ చేయడానికే ట్రాన్స్ఫార్మర్ కప్లింగ్ ఈస్ ఇంట్రడ్యూస్డ్. సో దాంట్లో ఉన్న డిసడ్వాంటేజెస్ విల్ బికమ్ ద అడ్వాంటేజెస్ ఇన్ ట్రాన్స్ఫార్మర్ కప్లింగ్. వాట్ ఆర్ ద డిసడ్వాంటేజెస్ ఇన్ ఆర్సీ కపుల్? మీరు చెప్పండి. వాట్ ఆర్ ద డిసడ్వాంటేజెస్ ఇన్ ఆర్సీ కపుల్ అండ్ హౌ అండ్ those are eliminated or reduced in transformer coupled. The disadvantages in RC coupled are eliminated in the transformer coupled. What are the three disadvantages in RC coupling? RC coupling disadvantages ఏంటి చెప్పండి. చెప్పాలి తొందరగా.
Loading effect, gain
Right? First disadvantage in the RC coupling is because of the coupling capacitor, gain falls at low frequencies. ఇక్కడ coupling capacitor లేదు. So this coupling capacitor does not give any effect on the uh, low frequency. So low frequency response is increased. Hello? Hello? Okay, so the basic disadvantages with the help of transformer couple is the first disadvantage is the gain falls at low frequencies. But the gain fall because the coupling capacity is not there. Gain fall at low frequencies is reduced, but because the gain fall at because of the effect of CE, gain fall is there. So మామూలు యాంప్లిఫైర్లో వచ్చినట్టుగా ఇలా రాకుండా గెయిన్ ఫ్రీక్వెన్సీ రెస్పాన్స్ విల్ గెట్ షార్ప్ frequency response. So low frequencies దగ్గర gain fall is very very less when compared to the RC couple, and this gain fall is because of CM emitter bypass capacitor CE. CE capacitor పెట్టినందుకు this gain fall at low frequencies occurs, and this gain fall is not because of the coupling capacitor, because coupling capacitors are not there. This gain fall does not depend on the coupling capacitor in case of transformer coupled. So that is reduced. The second disadvantage is impedance matching. So because you are using a transformer, so you need if you select the turns ratio N1 and N2 in such a way that the load output impedance, and the RL dash is nothing but what? The output impedance of A1 gain amplifier. The output impedance of amplifier and the input impedance of R1 are going to be matched, and the RL dash by RL ratio, RL dash by RI ratio is going to be equal to 1 with respect to N2 and N1 ratios, turns ratios. So you can get perfect impedance matching, perfect impedance matching with the help by selecting the values of turns ratio N1 and N2 in the transformer. So impedance matching is perfect impedance matching can be done with the help of transformer couple. Right? Once impedance matching is done, what happens? Loading effect is reduced. There is no loading effect. Loading is zero. No loading effect. No loading effect is present in the transformer couple, because there is no loading effect. Always the loading effect లేదు కాబట్టి always theoretical gain will be always equal to the practical gain in transformer couple. The theoretical gain will be always equal to the practical gain. Impedance matching efforts, loading effect is reduced, low frequency response is increased, and theoretical gain will be always equal to the practical gain. That means the basic disadvantages that occur in the RC couple are eliminated in the transformer couple. Right? All the disadvantages are reduced, became advantages in transformer couple. Always we have to use a transformer couple, but we are not using the transformer couple in as a preamplifier. And the preamplifiers లో transformer couple బదులు ఎందుకు why we are using the RC coupling? Because it is having some disadvantages. What are the disadvantages in transformer couple? Can you guess and tell me what are the basic
Very
disadvantages in transformer couple? Ma?
It is very bulky and cost will be very high, man.
Ah,
And poor frequency response. Spikes వస్తాయి కదా.
ah,
Non-linear distortion.
hmm.
అంతే.
ఫస్ట్ బేసిక్ డిసడ్వాంటేజ్ ఏంటి ఇక్కడ మనం ఏమంటున్నాము ఇవన్నీ అడ్వాంటేజెస్, బట్ స్టిల్ వీఆర్ నాట్ యూజింగ్ ద ట్రాన్స్ఫార్మర్. ఎందుకనంటే ఇక్కడ మనకి అడ్వాంటేజెస్ ఏంటి? ది సైజ్, కాస్ట్ అండ్ వెయిట్ ఆఫ్ ది ఆర్సీ కప్లింగ్ ఈజ్ వెరీ వెరీ లెస్, బట్ because we have introduced transformer at each and every stage. అంటే ఇక్కడ ఇన్పుట్లోనూ ఒక ట్రాన్స్ఫార్మర్ ఇంక్లూడ్ చేస్తుంది, దీని అవుట్పుట్లో ఇంకొక ట్రాన్స్ఫార్మర్ పెడుతుంది, అలాగే ఎవ్రీ స్టేజ్ దగ్గర ఒక ట్రాన్స్ఫార్మర్ పెడుతుంది. బికాస్ ఆఫ్ ద ట్రాన్స్ఫార్మర్ ప్రైమరీ, సెకండరీ వైండింగ్స్ అండ్ ద కోర్, ద సైజ్, కాస్ట్ అండ్ వెయిట్ ఆఫ్ ది amplifier increases. Right? So the size, weight and cost of the amplifier increases. ఇది డిసడ్వాంటేజ్. బట్ ఈ మూడు తక్కువ ఇన్ కేస్ ఆఫ్ ఆర్సీ కప్లింగ్, అక్కడ అది అడ్వాంటేజ్. సెకండ్ డిసడ్వాంటేజ్ ఇన్ కేస్ ఆఫ్ ట్రాన్స్ఫార్మర్ కప్లింగ్ is transformer వాడుతున్నందుకు, because we are using the core in the transformer, and the basic limitations on the transformer is at higher frequencies. Right? At high frequencies you will get some spikes in the signal. అంటే ఏంటి? ఇది ఫ్రీక్వెన్సీ రెస్పాన్స్. ఇది లో ఫ్రీక్వెన్సీ దగ్గర మనం లో ఫ్రీక్వెన్సీ రెస్పాన్స్ని we made a good and that means gain for and low frequency is reduced because of the elimination of coupling capacity. But what happens at high frequencies? At high frequencies, you are going to get spikes. Why we are getting these spikes at high frequencies? So these called high frequency spikes. Why we are getting these high frequency spikes? These high frequency spikes we are getting because of the core that are used in the transformer. Transformer core material will give um, um, unambiguous, or else we can say that so the core will at higher frequencies. Suddenly, the core is going to transfer more voltages or less voltages at higher frequencies. So, at high frequencies, the core will not respond in a normal way when compared to the low and mid frequencies. So, because of which you are going to get high frequency spikes that are going to get in the frequency response. So, ఇది మనకు కావాల్సిన frequency response ఏంటి? Required frequency response is this. Straight ఉండాలి. Gain in between two cutoff frequencies should be constant. And ఇక్కడ ఏమవుతుంది? We are getting some spikes in the gain response. We are getting spikes. So that is a basic disadvantage. That is the second disadvantage, that we are getting spikes. That is frequency response is not normal. Frequency response we are going to get spikes. So frequency response is not normal when compared to the RC couple. Third basic disadvantage is uh, because of the transform. The frequency response మనకి normal frequency response రావట్లేదు. Size cost weight కూడా పెరిగిపోయింది. So that is the reason why we are not using the transformer couple at for preamplifiers. So the base the other reason is fabrication into IC. Fabricating the transformer into IC is difficult. Into IC is difficult. I think you have already studied the fabrication process. IC net fabricate చేసాం. IC components normal resistor, capacitor, transistors మాత్రమే we can able to fabricate. If transformer is there, the fabrication process increases and a lot of errors will come in while we are fabricating. So transformer cannot be fabricated into small chip. So that is the reason why these amplifiers cannot be used in the pre-amplifiers. So pre-amplifier we are not using because we cannot make the multi-stage amplifiers into chips. So చిప్లో కంటే ఐసీలోకి కన్వర్ట్ చేయలేం కాబట్టి ట్రాన్స్ఫార్మర్ కపుల్ is not used. But where we are using the applications? చెప్పండి. Already we use this. Applications we use in the power amplifiers. Power amplifiers or transformer coupling is used. Power amplifiers ఎక్కడ యూస్నా? In the last stage of receivers. Where రిసీవర్లో మల్టీ స్టేజ్ యాంప్లిఫైర్స్ అన్నీ ఒక చిప్లో ఉంటే లాస్ట్ స్టేజ్లో వీఆర్ యూజింగ్ ది ట్రాన్స్ఫార్మర్ కపుల్. అది సెపరేట్గా సింగిల్గా ఐసీ ఫ్యాబ్రికేషన్లో ఉండకుండా వీఆర్ యూజింగ్ ది ట్రాన్స్ఫార్మర్ ఉంది separately. A small size of transformer that is going to connected in the design and the power amplifiers. So power amplifiers we are using transformer coupling. Right? So this is how we are going to differentiate. The first unit completely revolves around this three types of coupling: direct coupling, RC coupling, and transformer coupling. So transformer coupling lo meeru basic differences between transformer coupled basic ga దీని మీదే క్వశ్చన్ ఎక్కువ అడుగుతారు. ఒకవేళ నెక్స్ట్ క్లాస్లో విల్ డిస్కస్ ది ట్రాన్స్ఫార్మర్ కపుల్, హౌ వీఆర్ గోయింగ్ టు డూ ది ట్రాన్స్ఫార్మర్ కపుల్ రెస్పాన్స్ విత్ హెల్ప్ ఆఫ్. ఒకసారి మీరు నా నోట్స్ మీరు చదవండి. దాంట్లో వీఆర్ గోయింగ్ టు ఆర్సీ కపుల్డ్ మనం ఎట్లాగైతే చేస్తాము, హౌ వీఆర్ డూయింగ్ ది ఆర్సీ కపుల్, టూ స్టేజ్ ఆర్సీ కపుల్ యాంప్లిఫైయర్కి ట్రాన్స్ఫార్మర్ కపుల్డ్ యాంప్లిఫైయర్కి దెర్ ఇస్ నో మచ్ డిఫరెన్స్. ఎక్కడ డిఫరెన్స్ వస్తుంది? యాజ్ ఐ సెడ్ వీఆర్ గోయింగ్ టు యూస్ ఆర్ఎల్ డాష్ ఇన్స్టెడ్ ఆఫ్ ఆర్సీ. RC is replaced with RL dash. Okay. RI ne untundi. RC is replaced with RL dash, where RL dash will be equal to N2 by N1 whole square into RI. Ante. ఎక్కడెక్కడైతే ఆర్సీ ఉందో ఆర్సీ కపుల్ టూ స్టేజ్ ఆర్సీ కపుల్లో ఆర్సీ ఉన్న ప్లేస్లో RL dash is replaced, where RL dash value will be equal to N2 by N1 whole square into RI. మిగతా మొత్తం ప్రొసీజర్, the rest of the procedure for calculating the gain at low frequency, mid frequency and high frequency is same. మీరు ఒకసారి దాన్ని చెప్పండి. అక్కడ ఏమైనా మీకు డౌట్స్ ఉంటే నెక్స్ట్ క్లాస్ థర్స్డే రోజు విల్ డిస్కస్. నెక్స్ట్ క్లాస్ స్టార్ట్ అవుతుంది కాబట్టి ఐఎమ్ గోయింగ్ టు క్విట్ నౌ. మీకు ఏమైనా డౌట్స్ ఉంటే చెప్పండి. అదే క్లోజ్. దీప్తి మ్యామ్ ఈస్ వెయిటింగ్ ఫర్ యూ. ఓకే,
మ్యామ్ నెక్స్ట్ క్లాస్లో టూ స్టేజ్ అనాలిసిస్ ఆఫ్ ఆర్టీ కపుల్డ్ ఫెట్ యాంప్లిఫైర్ది చెప్తారా మ్యామ్?
పెట్టాను. ఓకే, సరే
ఓకే
చెప్తాను.
మ్యామ్, థ్యాంక్ యూ.
పెట్టు, టూ స్టేజ్ పెట్టు, టూ స్టేజ్ ట్రాన్స్ఫార్మర్ కపుల్డ్ ఒకసారి విల్ డిస్కస్ క్లోజ్ టు.
ఓకే మ్యామ్, థ్యాంక్ యూ.
ఓకే, సరే బాయ్. ఒక నిమిషం మీరు ఒకసారి అటెండెన్స్ తీసుకుని స్క్రీన్ షాట్ తీసుకుంటారు. ఒక నిమిషం. వెళ్ళి డేట్ ఎంత? డేట్ ఎంత?
మ్యామ్
డేట్
23rd.
ఓకే 23rd. ఓకే, తెలియదు. మీరు లీవ్ అవ్వచ్చమ్మా, నెక్స్ట్ క్లాస్కి వెళ్ళండి.
ఓకే మ్యామ్.